So again, we start this old exam, with a series of predict the products questions. In part A, we have a nucleophilic addition to a ketone. Now, there's also an alkene present in this molecule, but in this case, we don't have to worry about the alkene because it's not conjugated into the carbonyl, and therefore it won't affect any nucleophilic addition. So our nucleophile, the nitrile or the cyano group, we'll just add directly to the carbonyl. The alkene is unaffected, and we get the product pictured here. Part B is the reaction of an alcohol with a strong base, sodium hydride, and then an alkyl halide. And so this looks like a Williamson ether synthesis. However, we want to remember that in a Williamson ether synthesis, this is really just a specific example of an SN2 reaction. And SN2 reactions don't work with sp2 leaving groups, and so therefore this reaction is not going to work at all. Part C, we see this phosphorus double bonded to carbon, which we know is known as an ylide. That means we're dealing with a Wittig reaction, where the carbon of the ylide forms a double bond with the carbon of the carbonyl, giving us that product. One too many carbons there, so let's fix that. 3 carbons matching the 3 carbons in the ylide. All right, in part D, we have this ether, and we're heating up to high temperature. So this is known as the Claisen rearrangement. And I'll include the solution here, although this is a reaction that now I generally don't cover till the very end of Organic 2. But in the Claisen rearrangement is basically a rearrangement of the pi electrons as well as some of the double bond electrons. It goes through a cyclic transition state, which is why I ended up moving this to the time in the course when we get to things like the Diels-Alder, because it just makes more sense in that material. But what happens here is we get a series of electrons to move and end up with the group that's on the oxygen shifting over 1 carbon and giving us an alcohol. But as I said, if you're watching this video, most likely you're preparing for material within the first half of Organic 2. And so right now I don't cover the Claisen rearrangement this early in the course, and to be honest, it may be the very last thing we cover. So you probably haven't seen this reaction yet, and if you haven't, don't be too concerned about that. Part E is an alcohol oxidation using PCC. Now we have 2 alcohols in this molecule, but recall that only secondary alcohols, such as the one up at the top, can oxidize, and primary alcohols can oxidize. We're not worried about primary alcohols because there are none here. But this alcohol down here at the bottom is a tertiary alcohol. Tertiary alcohols don't have any hydrogens to give up for an oxidation, and so that alcohol won't react, and so we end up only oxidizing the alcohol at the top. In part F, we have the addition of I- to a conjugated ketone. So when we have addition to a conjugated ketone, we need to distinguish between 1,2 and 1,4 addition. We know that we get 1,2 addition first, and we only get 1,4 addition if our nucleophile is also a good leaving group. So the question here is I- a good leaving group? And we've talked about that halogens, with the exception of fluorine, are all good leaving groups, iodine in fact being the best of them. So given that it is a good leaving group, it will do a 1,4 addition and add at this position. Part G is the reaction of an alcohol with TMS chloride. This is an example of a protecting group reaction for an alcohol, and so the oxygen gets substituted with the TMS, or the trimethylsilyl group. And part H, we have a nitrile. That nitrile, under acidic conditions, gets converted to the carboxylic acid.